Terafab could become the most ambitious semiconductor project ever attached to the Musk ecosystem. But this is not a finished factory, and it is not a blank check. Here are 10 remarkable facts that the official filings actually support, and the fine print investors cannot ignore. Number 10. It was announced as a Tesla and SpaceX collaboration. SpaceX says the initiative was announced in March 2026. Tesla describes the partnership as an attempt to build the largest chip fab ever. That makes Terafab a bridge between Tesla's physical AI roadmap and SpaceX's orbital compute ambitions. Number 9. Intel joined the project in April 2026. SpaceX says Intel brings the ability to design, fabricate, and package ultra-high-performance chips at scale. That matters because building an advanced semiconductor plant is far harder than designing a chip. Process technology, yield, packaging, and volume production all have to work together. Number 8. The long-term goal is 1 terawatt of compute hardware every year. That is not a conventional wafer output target. It measures the useful computing power of the finished hardware. SpaceX presents it as a long-range ambition, not a current production rate, and no official timetable has been disclosed. Number 7. Terafab is designed around 2 different chip families. One would be optimized for terrestrial edge inference, primarily for Tesla vehicles and Optimus robots. The other would be optimized for the space environment and SpaceX's planned orbital compute infrastructure. One manufacturing strategy, 2 radically different operating worlds. Number 6. The vision reaches from lithography masks to advanced packaging. SpaceX says Terafab would vertically integrate mask design, logic fabrication, memory fabrication, and packaging inside one closed-loop plant. The goal is faster feedback. Design a chip, manufacture it, test it, and push the lessons into the next version with fewer organizational handoffs. Number 5. Tesla says the effort begins with a company-owned research fab at Gigafactory, Texas. That detail turns Terafab from a distant slogan into a staged development path. A research fab can validate processes, train teams, and expose production problems before anyone attempts the full scale implied by the name. Number 4. Chip supply is the strategic problem Terafab is meant to solve. Tesla expects demand from robotaxi and Optimus to outgrow existing and planned industry capacity. SpaceX says internal manufacturing could reduce future shortages, improve performance, and potentially lower compute costs as its AI infrastructure expands. Number 3. Terafab is not supposed to replace every outside supplier. SpaceX explicitly says it expects to keep buying a significant share of its compute hardware from third parties. The internal fab is described as complementary, another supply channel, and a way to control the most specialized parts of the stack. Number 2. The space chips could change the economics of orbital AI. General-purpose processors are not automatically ideal for radiation, thermal cycling, power limits, and long service lives in orbit. SpaceX wants chips designed for that environment, paired with reusable launch and solar-powered satellites. If it works, Terafab becomes part of the cost-per-token equation in space. Number 1. The most important fact is the caveat. SpaceX told the SEC that its arrangement with Tesla is a general framework. Individual projects still require separate negotiations, agreements, and board approval. Neither Tesla nor Intel is obligated to remain, and timelines, milestones, and capital spending have not been finalized. That is the real Terafab story. A plan to fuse chip design, fabrication, memory, packaging, vehicles, robots, and orbital compute at unprecedented scale, backed by serious industrial partners, but still carrying major execution and governance risk. Watch for definitive agreements, site expansion, equipment orders, production milestones, and disclosed capital commitments. Until then, 1 terawatt is the destination, not the starting line.